Okay, this is a test of my variation on the Magnetic-Bearing-Oldham coupler. I've done a couple of other videos on the basics. As you can see, there's a reasonable degree of freedom there. And this is just a mop together Z axis to show that if you wobble the Z as you go up, there's absolutely no need for the bed to wobble. And all I'm doing with these two fingers is constraining it the same way that a smooth rod or a linear rail would constrain the bed's motion, and then allow the lead screw to wobble to its heart's content. Obviously, there's only about 1.5 to 2 millimeters of play, so hopefully nobody's lead screw is that bad. But as you can see, there's a little bit of backlash in the middle at the moment. That's only because the two segments in the middle aren't glued together, and there's a little bit of play. But other than that, this is pretty solid, and turning it, there's very little slop there. The only possible problem is when the bed drops, there's nothing constraining this downwards. Obviously the gravity and the weight of the bed is constraining it upwards, but so there's the potential for these to lift. They're magnetically coupled, but you know, magnets are only so strong. I mean, if you just shake it, you can see it doesn't fall off, even with no weight on it at all. And there's a hard limit to where the bearings are allowed to move, so the bearings should never fall off. But yeah, I've got a version that I can actually put on my Mercury one, printing at the moment. Obviously I would cut these down when I've finalised the design, but I didn't want to do that on the off chance I wanted to make these blocks slightly bigger or slightly smaller. But yeah, it seems to be working. The fact that there's 4 bearings per layer stops there being problems with tilt in this direction or in this direction, and 4 rather than 3 makes it a lot easier for the rods that are actually acting as sort of rails for the bearings to be structural rather than just very short pieces. Because if you've got very short pieces, then it's entirely up to the accuracy of the print to determine whether or not they're in the place that you intend them to be. Whereas when you've got a hole going through the entire length of the print, it's a lot easier for any small errors to be bored out with a screw, with a drill, or just pushed out by the strength of the steel rods.